Hello folks, welcome to Let's Fix Computers. This video is going to be a little bit different from the normal. It's an edited down live stream from Two Guys Talk Tech that we did a couple of months ago. Caradog and I were looking at a couple of Dell Latitude motherboards that had charging faults, and we ended up doing a halfway competent repair of one of them that I thought would make for a good standalone video. Friend of the channel, Bald, was kind enough to edit down this 3-hour long waffle to something that was a bit more accessible. So here we go, everyone. Okay, so this laptop does turn on and work, but the left-hand port does not charge, which is a common failure mode on these Latitude 7420s. So I want to see if I can get it to charge on that port. Okay, so what I'm going to do is I'm going to see if I've got that other one. This one's going to have a different well, does it have a different charge chip in it? Let's find out.
Is it actually the chip itself that's the issue?
Yeah, 99% certain it's the chip. On Dell's implementation here for their Type-C ports, they have a Thunderbolt controller chip, and then there is a separate chip that is handling power. And it's the power chip that's gone wrong, because they still function as USB ports. You just can't charge the laptop over them, which is kind of a problem because they charge over their Type-C charging only. I could sell this laptop as is, because the USB port does work as a USB port, but the annoying thing is that I'm going to get situations where even if I tell the customer, oh yeah, you charge it on the right-hand port, they're going to come back a week later saying it won't charge because they're plugging it into the wrong side. It's a recipe for a return. I'm going to try and fix that. At the very least, I would have to discount the laptop because it technically has a fault. Let's open up the broken one and actually look at the port that needs to be replaced. So I said it was the left-hand port. This is the one that's on that annoying daughter board, because I replaced that before at one time and it didn't fix it. And the reason for that is that the chip that is on that board is the Thunderbolt chip, but the charge chip is on the main motherboard.
Oh, they're not both on that. Oh, that's wildly
That's
annoying.
why it didn't work that one time I replaced that board.
Yeah, that's wildly annoying.
Yeah.
Because if you're making a separate daughter board, I can understand having both chips on there.
Yeah.
Because they're the ones that are likely to get damaged by the customer doing something silly.
Yeah. But for reasons unknown, they put the charge chip on the motherboard instead of on that little daughter board.
Oh, yeah.
Maybe that's just because the charger chip needs to be adjacent to just power stuff, like, you know, capacitors, inductors, etc., and they just couldn't fit all of that on the board. I've taken this out. I'll take a picture of it with my phone.
Yeah.
Right, which one is it? Pretty sure it's that guy there. No, it's not. It's that guy there, I think. It is a 65992S, I think. These things do have firmware, but apparently either the PCH or the EC, whichever one, will automatically update the firmware on the chip if you replace the chip.
£14, apparently.
Daylight robbery, but 14 quid to make the laptop fully functional again, I would pay that. That's coming from China though. Let's have a look at the AliExpress price. In the meantime, I'm going to take apart the other laptop and see if it's got the same chip in it. Because if it has, I will steal it.
AliExpress.com.
Here's another 7420, and I was about to be like, riddle me this, why is this one in pieces? However, I can see that the same chip has exploded on this one. So is there a second one of those chips? Let's put that to the test actually. If I just plug this in, it should take some power. However, because that chip has actually exploded, the whole thing might be stone dead, so I'm just going to quickly check that. If this motherboard is stone dead, then I can just start stealing stuff from it guilt-free. No, that works. So this is the question, like I could steal the chip from this one to put it on the other one and just see if I can make one working one today and then just put 2 new ones on this one. Sure, why not? Yeah, I can't think of a reason not to do that at this point. The number of chips that needs to be replaced remains the same. I'm going to quickly stick this under the scope and just hot air that chip off and then hot air it onto the other one. Then we'll put it back together again and see if it works. So yeah, cool. All right, let's do that. We've Google searched the data sheet for this, so here's the data sheet for this chip. So there's the pinout. Table of contents near the top will probably be more useful. Failing that, if you literally just start scrolling, you'll probably find it's near the top, to be honest. Revision history, yeah, just keep scrolling, keep scrolling, keep scrolling. Pin configuration, keep going. There'll be one where it's just like package sizes and stuff like that. This stuff is normally near the top of a sheet. Blah, 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 blah. because usually the chip is available in a couple of different packages. Yeah, characteristic curves, chip timings, how to talk to the chip.
Yes.
Functional block diagram, the basics of what the chip does. Unironically, at some point it can be interesting just to look through data sheets because they do tell you how the chip works. That's what the data sheet is for, is to tell you how the thing works and the principles of operation and stuff. And then somewhere in here, it will usually have here's what the chip looks like and here's what all the numbers on it mean. Oh, here we go. There's going to be like typical applications of the chip, how you could use it. This is how you would mount it, where you should put the capacitors.
Wow. This is a lot more kind of information than I was expecting them to give you.
Yeah, this is why I said it's worth just scrolling through it. This is exactly what I mean, because you'll be like, oh, interesting. Yeah, see, look, if you buy it, this is how you can expect to see it. So here's how big the reel is. Here's what machine it fits in and stuff like that. Here's the box that the reel comes in. See what I mean?
Wow.
Here's how physically big the chip is. Because if you're designing a circuit board, you need to know how big the chip is.
Yeah, but I half expected them to just be like, lol, work it out.
There are good, this is Texas Instruments, so it's all there. Yeah. But, there are some chips where just they're like, lol, work it out. But this is TI, so yeah, you get a full fat one.
I just didn't realise there would kind of be that amount of information, just kind of effectively freely available.
This is literally an instruction manual for it. All right, I'm going to take this chip off the board. Why are these lightning chips going bad? Don't know. Just common failure point, I guess.
But it's interesting that it's the left ones.
Yeah, it's always the left.
Even though it's the same chip between left and right.
I don't know why. Maybe it's because...
I wonder if they all got docked on the left-hand side and just they all came from the same company and they all used only the left port for power and docking and stuff.
Maybe
they didn't actually use the right-hand port for power at all.
This one, as you can see, is physically exploded. I can't see any reason. I was going to say maybe it's too close to something else that's hot. I don't know. I don't know why it's always this side that blows up. Maybe this one is the one that gets the most usage because the left port is clearly the one that's intended for use as the main charge port. The right-hand port doesn't have a charger symbol next to it. It just happens to also be able to charge it.
Oh, doesn't it?
Yeah.
Oh, I see, okay.
They're both identical, but the one on the left actually has the charge symbol next to it saying this is the charging port.
Therefore, average user is going to only use that one for charging.
Exactly. So maybe it's just mileage.
Yeah.
Just this chip just gets an awful lot more mileage put on it. Right, let's rip this guy off. Tweezer check. Yep, that'll do. Okay. I don't mind paying double the price for a single one from eBay if it's going to arrive in 2 days.
Yeah.
But when I'm paying like £7 for one chip and it's shipping from China, I'm like, okay, why shouldn't I just go to AliExpress now?
Yeah.
I'll pay a premium if I'm going to get it in 2 days.
Yeah.
But if I'm waiting for it to come in from China, I may as well go directly to AliExpress at that point. That was nice and painless.
I guess if you wanted to buy a reel, you'd go to Alibaba.
You could probably find reels on AliExpress, but yeah, if you're actually buying in bulk, you should be talking to Alibaba at that point. Right, I shall put that down there and get the other board. So this one, we're going to remove the left port chip, which is this one. That has not visibly exploded. Although, what's going on with that? Let's take the chip off and find out.
So is this chip just purely doing, effectively, the logic of charging? Or is it actually carrying power?
It is carrying power. You'll notice... Oh, I just put my palm in the thermal paste. Rip. All right. You'll notice we've got big fat traces going to here. Like these two pins are going to a single trace. These two pins are going to a single trace. So you can see we've got an in and an out going on here.
And those two pins are enough to do 60 watts?
I guess, yeah. I think it's just because we've got a lot of width. This is the thing, is you look at traces and you'll be like, is that trace really doing like 60 watts of power? When you factor in the cross-sectional area, it's very flat, but it's very wide, versus a wire in a cable, which is thicker but also round. So again, if you factor in cross-sectional area, suddenly you're like, oh yeah, I guess so, yeah.
It was more the contact patch for the actual leg bump, effectively. A real consideration for 240 watt USB-C is actually the port itself, the physical connection on the power pins. No, I hadn't overly thought about that, but that's why they doubled the voltage.
Oh, yeah,
do
yeah, 'cause
240.
it brings the current down.
So the current stays at 5 amps.
That's right, yeah. Yeah, that's how you solve that problem. Cool, right. Same deal, flux. Okay, so, having removed that chip, can't see any signs of distress on it.
That's a good or a bad thing?
Well, I like signs of distress because it confirms that it was dead. It's kind of nice when you take a component off and you see a crack or a hole in it, because you're like, yeah, there's your problem, you know. I know from logic that this must be it, but whatever that tiny bit of silver we saw is gone, but it might have just been a little solder ball where the chip has overheated at some point. That's not uncommon. Right, okay, that's the chip I just took off. I have already lost the other chip. Like, I actually have no memory on what I did with it. I'm not joking.
So the one you've just taken off?
Right, the one I've just taken off is here. It's in my hand. I put it there to the side of the mouse mat where my tweezers are. The first chip that I took off the first board, did I carry it over here and put it down? No, I brought the motherboard over here.
It's on your hand.
It's on my hand. I'm not drunk yet, like, not even slightly. This is just streamer brain.
You have, in fact, attached it to your hand.
Okay, right, next problem. I didn't pay attention to what way round the chip went. So we've got a little white square there. That indicates pin 1. So this guy should have a dot on it that indicates pin 1. So that should go that way round. I'm going to run some leaded solder over those just to make my life a little bit easier. It should just make it a little bit easier to reflow the new chip. What am I at? 380. That should be enough. I'm just going to go blah over all of that and try not to knock everything off around the sides. I'm looking around and most of these pads are empty, and I'm like, is that because I knocked all of them off? Right, let's try and pick off some of that solder now. I think I missed half of those pads, but there was an attempt. Right, I'm going to pull up a little bit of that solder because there's too much. Wick. Oh, I don't have enough heat for that. That'll do. Okay, that should do. That looks a bit rough, actually. Oh, my life. Okay. More flux and then I'll try that again. I put on too much solder and none of it went to the places I wanted. This is why I hate ground pads, because all of the solder just goes directly onto the ground pad. Come on, help me out here, motherboard. Work with me here. I think I'm just going to solder this thing down and then just run the iron around the edges anyway. Because I'm going to have to do that anyway, so yeah, that'll do. Fine. I'll clean up the burnt flux, put some fresh stuff down, and we'll just get on with it. Boop, boop.
I guess technically you can use the same solder over and over and over and over. It's just the flux amount would change. So if you were adding flux, you could, because you're not chemically changing the solder.
Yeah, pretty much. I mean, the solder is still going to oxidize, so you'll get like slag, but a lot of the time that comes off on the iron.
Yeah.
It comes out in like the burnt flux and stuff like that. So, yesn't. You can reuse the solder to a large extent, but it does still wear out though. Right, chip. Cool. Right. Lift flux. Cartoon splat noise. Gonna hold it roughly in place while we get things going. There you go. Look at that dance. Can you see the chip wiggling?
Oh, it's funny seeing all the other pads just kind of go.
It's very satisfying, isn't it? Okay, right, that's soldered down. Now we just need to fix all the pads. Theoretically, I can just run this around the edges now. Just making sure I get nice blobs on all the legs. Let's clean that up and see what it looks like. Yeah, I'm going to give that another pass. There we go, that's more like it. Whoops, that's too much solder. That's better. That's more like it. Alright, that's good enough for Australia. See if it works. Okay, right, this is all dead.
And if it wasn't, it is now.
Yeah, well, I'll probably buy those ones that we saw, that 5-pack of whatever, because then I can put 2 new ones on this one, and then theoretically this can be reassembled into a working laptop.
Yeah.
And then I'll have another laptop to sell. In the meantime, let's put this in and see if it works. So I might be able to tell just by plugging in the daughter board. So let's put that to the test. Take this out from here.
Oh, it's the left port on the daughter port. Yeah.
That's right. Okay, right. So firstly, this is a Latitude 7420. These are 11th gen i5s. I think they're 11th.
That's what you said.
Yeah, 10th or 11th. I think they're 10th. Yeah, they're 10th or 11th gen i5s. These are good modern workhorse laptops. Absolutely worth saving. These are the ones that I like to sell in my shop.
This is the 20, isn't it?
Yes.
Yeah, they're 11th
correct.
gen.
Yeah. Right, so this was the original known good port. So when I plug this in, I should get power delivery indicator here. So we've got
I've pushed this button.
wattage and then power delivery. So it's negotiated power delivery. So this port was already working. So the board still works. We didn't kill the board. Good.
Oh, I see. Yes, because it can't do the PD negotiation.
If the chip doesn't work, because the chip is what is doing the negotiation. So now I'll put this on. This is the left-hand port. This is the one that doesn't work. So now I put this on and try this one. If this one negotiates power delivery, it means that I win.
They're all soldered RAM, aren't they?
Yes, they are. That's one of the disadvantages of these things. It's soldered RAM, but beggars can't be choosers these days, unfortunately. These are still some of the best reconditioned laptops you can buy.
It was just a case, so I couldn't remember if it was this one or the next one they swapped out.
Yeah, look at that. Power delivery.
Hey!
It's working! It's working! Right, I'm going to put this laptop back together again, and I win. Cartoon splat noise. I feel like I'm missing half of this. I've got to put some screws in the motherboard. I think that's what I'm missing.
And also you'll need an SSD.
I've got the one that I took out. That should have a Windows install on it. Because all of these, as soon as they come in, I take them out the box, I take them apart, and I do the thermal paste and re-image the SSD. So that SSD just should have a generic Windows install on it. Okay, this is the right-hand port. This one already worked. Cool. That is charging the battery. We are pulling 18 watts of power, 20 watts of power. The laptop is turning on. I'm going to let the laptop turn on and post just because the battery might be flat, so I'm just going to let it sort itself out. Time of day not set. Okay, let's go into BIOS setup. The battery on this is charged. I've got a 45-watt charger plugged into this thing at the moment, so that is working. We run on battery. So battery is discharging, AC adapter not installed. So let's plug it into the left-hand side. 45 watts. And the battery state is going to stay on idle because it's at 99%. I'll be surprised if it starts charging, but still. The point is, yeah, that's working.
So, and it can actually run off of USB?
Yeah.
Oh, that's good. Without running via the battery?
Yeah, every laptop can do that, theoretically.
Yeah.
Some laptops require the battery to be connected just because of reasons, just because the battery not being connected is considered an error state. So it will say there is an error, therefore I will not turn on. However, all laptops, there is no such thing as powering through the battery. Even though mobile phones infamously will usually not power on without a battery, that's just purely because of error state. Theoretically, in a hybrid power architecture, the laptop is supposed to be able to draw from the battery and the charger at the same time. Therefore, it requires the battery to be connected. But in reality, I think there are very, 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 very few laptops that actually do that, in my experience. Good. That works. I'm happy with that. That's a good result. Man, what a story. Well, I hope you guys found that interesting. Thank you very much, and I'll see you all in the next video. Bye for now.